Okay, next up, we have George and Charlie. George is a general manager at Trace Labs, where he leads the company's key projects, deploying trusted AI solutions powered by OriginTrail in collaboration with global partners. And then Charlie is an investor at ID Theory, a liquid and venture-focused crypto fund that invests in the next trillion users over 3 verticals, which are decentralized AI, DeFi, and DeSci. Cool.
Hi, thanks for the intro. So, just for clarity, my name is not George. That's probably the English translation of it, so Yuri. But I go by George sometimes as well, so it's fine. All right, fantastic. So, thanks for the intro. We're going to be talking today, and Charlie will come on the stage a little bit later, about decentralized science on the decentralized knowledge graph. So, now we got it. Okay, thanks. So before going into the details, I'd like to just set the scene a little bit by exploring the history of knowledge, so to speak. So humanity has had 3 big, large knowledge revolutions that really propelled humanity forward. The first one being the Gutenberg's printing press that really, before that invention came to be, knowledge was really concentrated in the hands of very few people. It was very difficult to be replicated. If you wanted to copy a book, you had to rewrite it, literally. And then the printing press came, and all of a sudden, books could be printed, and knowledge really was distributed to a scale that was, not possible before. And that was what, some 580 years ago now, kind of ushered in an era of knowledge dissemination for humanity, right? And then a couple of hundred years, well, quite a couple of hundred years later, the internet came about, right? And the internet enabled this knowledge. So now you didn't have to go into the library anymore. You could access knowledge online. You could even produce knowledge. Everything was a lot more connected. So it really kind of sped up the cycle of how knowledge was consumed and how knowledge was generated by people. So arguably, both of these 2 inventions, they had some very good impact on humanity overall. Of course, a couple of pathologies were present as well, but overall, very positive impact. And now we're in the midst of the AI revolution, right? So we are kind of building on the internet, and the question here really becomes, how do we enable AI to reach its full potential? So to avoid the pitfalls, to avoid the risks that actually have, surfaced already quite often in the past year and the past couple of years, and are related to everything from IP protection to actually being able to trust what you see, and so on and so forth. And what we see here is actually 3 building blocks that need to happen for AI to unlock AI's full potential. The first one being information provenance and verifiability. Now, what does this mean? This means, I'm sure everyone here has at least sometimes used tools like ChatGPT, Gemini, and whatnot. How often do you get an answer that you can't really verify? It's coming from somewhere, might have some source attached to it. You don't know who issued it. You don't know who wrote that. So how can you trust the answer that the AI generated, right? So if you want to have full potential of AI, this is kind of it must be rooted in information, in verifiable information. And that's especially important, what Charlie will talk about later, for scientific research, right? You need to trust what you see, otherwise you're kind of, even if it's 90% correct, it doesn't really work, right? The second piece is around data ownership, right? So we have challenges with IP protection models being trained on data they shouldn't be trained on. Recently, it was just like what, Scarlett Johansson and OpenAI again with some clash, right? So the infrastructure that supports AI needs to have data ownership built in, so everybody gets what they're due, right? The value is distributed. And the third and last piece that we see as really, really critical is embedded incentives. So we need to have a mechanism that incentivizes people to produce quality knowledge, so that AI can use that quality knowledge either for research, either for training, or for whatever purpose we would use AI in the future. And Jan LeCun, the Turing Award winner, phrases this really nicely in his quote, right? So the AI systems will have to be crowdsourced, and if you want them to be a repository of all human knowledge, all humans need to contribute to it, or at least have the ability and option to contribute to it. And this is where verifiable internet for AI comes in. And what is the verifiable internet for artificial intelligence? We see this as an intersection of crypto, internet, and AI. And OriginTrail is one of the core components that we see as enabling this verifiable internet for AI. And OriginTrail introduces a couple of really exciting concepts and components. The first one being the data is organized in a decentralized knowledge graph, meaning it's highly structured, it's highly connected, it spans across individuals, it spans across organizations, enabling any AI system actually to tap into it, right, and have a lot more, let's say, knowledge available to do research, to answer questions, to answer prompts, queries, and whatnot. Going one step further, for those of you who are in the AI field, you probably have heard of retrieval augmented generation, which is a framework where you find some external knowledge, you feed it to the AI, and AI does a summarization kind of based on the input of the knowledge that you provided, right? To maximize accuracy, to increase actually usability of AI. Now, OriginTrail introduces something called Decentralized RAG, Decentralized Retrieval Augmented Generation, which enhances this concept by allowing not only more precise extraction of knowledge, specifically important for scientific research, right? You need to be able to extract the right pieces to be able to use AI in a trusted way, but also that all of those pieces that you extract are actually verifiable in terms of who issued them, who modified them, who is the current owner, and so on and so forth. So that's a very important piece. And all of this verifiability and trust is rooted in blockchain. And blockchains, OriginTrail is a multi-chain system. We'll cover that a little bit later. It can connect to several ones. So that's one last thing that it introduces. So one really cool thing is the incentivization of knowledge creation through tokens. So that's also a very important piece if we want to generate quality knowledge, as mentioned before. And we'll see a little bit later how that works exactly. So for more details, you guys can scan the QR code. That's the white paper that we released a couple of months ago that talks about these concepts in a bit more detail. Just a quick example of how the decentralized retrieval augmentation and OriginTrail work in practice. So we did a little test of the GPT-4o when it was released a couple of weeks back, and did a test just GPT-4o with browsing capabilities, and then we integrated it into the chat DKG and the OriginTrail framework. And this is the answer that we got. It was a sustainability question around Heineken's Scope 3 emissions in 2022, broken down by category. We get some answer that is not really what we asked for, some reduction, no numbers, no categories, some source. Okay, it's something not great, right? Well, kind of terrible. This is the same question on chat DKG using the same model, right? So it's what were Heineken's Scope 3 emissions broken down by category, because we have Heineken's carbon emission report as a knowledge asset in that decentralized knowledge graph. The AI is able to extract the knowledge and answer all of these things in a lot more detail. And of course, you can see up there, we'll get a laser probably here. So in the here you can also see the source knowledge asset, which means that this Heineken report, somebody issued it. In this case, it was OriginTrail as a demo to actually be able to for AI to be able to access it. So very kind of plastic example, but just to give you an understanding of how what a difference these things can make. Last thing I'll introduce is the concept of knowledge paranets. So I introduced the OriginTrail decentralized knowledge graph. So knowledge paranets are, let's say, clusters of knowledge in the decentralized knowledge graph that have that focus on a specific topic, and they have specific AI agents, services associated with them. So AI solutions can actually tap into them, use them. Now, they're led by and created and led by a paranet operator who defines all of these parameters. So what will the blockchain be? What will the AI services be? What ontologies should be used so that the knowledge is actually useful? What quality checks will be performed? All of these types of things. And the last but not least, these paranets can be incentivized. And I think that's what I mentioned before. You can submit a governance proposal on Euroweb, which is a blockchain on Polkadot tailored to the decentralized knowledge graph. And if the community votes that this makes sense, that this knowledge is valuable to humanity, we can have incentivized paranets, meaning that anybody in the world can mine knowledge. And if the knowledge is of expected quality, they can get compensated with neuro tokens. And all of these paranets at the end of the day, right, you can have solutions that tap into one paranet or multiple paranets depending on what you're using the AI solutions for, and do really, really awesome things. Last thing for me is just a quick insight into the future. We have the decentralized knowledge graph version 6 running for about a year and a half. We have a lot of solutions that are utilizing it in the enterprise world. So from the British Standards Institutions, the SCAN, which is kind of like a aggregate of all largest retailers in the US that use this to exchange audit reports, to travel safety with Swiss Railways and so on and so forth. But what we have upcoming with version 8 is really even 100 times more exciting. So we have a bunch of scalability updates upcoming to support the growth of these paranets that we just went through. A bunch of new AI integrations, specifically also targeting AI agents that can do all sorts of awesome things. DPIN, right? So for private knowledge, so that you can use your phones, mobile devices as also a store for private components. Not everything needs to be public, of course. Multi-chain growth, expanding into additional blockchains. And of course, at the end, the autonomous DKG. And what does this mean? Once we have a lot of paranets, a lot of knowledge assets, a lot of knowledge connected on the decentralized knowledge graph, the knowledge graph through inference can actually grow new knowledge on its own, right? So it can expand and grow without actually people needing to interact with it at all. And that will be it from my side. Charlie, hope it didn't take too much time, because I forgot to put the timer, but I'll pass over to you.
Thanks, George. Ooh, thanks, George. Thank you. Nice to be here. Thanks, everyone, for having me. If you are still awake at this late stage, I hope you're wondering how DKGs can actually improve DeSci. Jurij has already been through many of these, and I'll take you through them one by one just so we can hit the point home. But the main point really is, what most of you have already talked about today, is how can we better coordinate as we unravel from our old institutions into our new shiny ones? How can we coordinate across the globe with all of us pushing towards the same goals? And knowledge graphs, as Jurij already said, are very good for compiling composable stores of data that we can make new complex relations with other people and coordinate. But decentralized knowledge graphs add some new things into the mix. So in terms of scalability and composability, we obviously all know about blockchains. They're very good for establishing trust, but not for all forms of data. And then data held outside of these is very hard to share selectively and make those collaborations across borders. Whereas the solution Jurij outlined with DKGs plus the blockchains, they're a lot better for dynamic scientific data and complex relationships that I'm sure many of you are working with in your studies. That means that we can make them more scalable, more collaborative, and more machine readable, which is what we'll get onto a little bit later. Verification, obviously, a very important part of it when we're talking about scientific assets. Scaling truth and trust across scientists across the globe is very difficult, especially if we have no aligned framework for it. And using the DKG for data provenance will be especially important for scientific models, especially when you start looking at hallucinations and biases. I'm sure many of you experienced using one of these models and come up with a hallucination. And honestly, some of them are quite funny, and some of the biases are quite funny and well documented. But when it comes to science, it gets a little bit more life or death. We can't be basing any of these breakthroughs on this stuff. In terms of ownership and privacy, again, massive part of it. Storing and monetizing important or sensitive data is very tricky today. Whereas in the DKG, scientific data can be wrapped as knowledge assets with tailored data management, and you can have attribution if you wish, optional privacy for assets that need it, and you can monetize if your asset so deserves it in the future. So I work at ID Theory. We had a nice little intro there with the tagline. So we're a crypto-focused fund, investing in decentralized AI, science, and finance, and anything in between, really. And internally, we spend a lot of time thinking and mapping out the future of what we think that should look like, and trying to work and build towards that with other founders. Our co-founder James has written this DeSci blueprint. I don't know if anyone's come across it, but it's a very good read. I recommend if you've got some time after this. But through all that time, finding the correct partners is not always easy. And with something in your head that you think would be perfect isn't always ready built. So this time around, we wanted to roll up our sleeves, get our hands a little bit dirty, and start build towards that future we wanted to see. And we came across Jurij and the guys at OriginTrail. It really was like a match made in heaven in terms of what we're trying to achieve. So the simple goal is to establish the ground truth for autonomous research and decentralized scientific advancement. Sounds pretty easy. Might take us a little bit of time to get there, and we'll get on timelines in a second. And what we're setting up is a framework for knowledge mining on science-specific research, where users can receive incentives for adding and indexing and verifying relevant scientific data onto the DeSci paranet. And then in the future, there will also be incentives creating AI tools for accessing the research and value inferencing of the new knowledge. At the moment, we're going to be building a query and DRAG interface, which we'll be demoing later, but then more sector-specific apps or services can be done in the future. So you can kind of imagine some kind of gene paranet where decentralized 23andMe apps on top, providing rewards back to the data used, which is a pretty cool feature. I'll walk through some timelines quickly and what we're hoping to achieve in the further future. So we have short, medium, and long-term goals with this paranet. The V1, which hopefully will be Q3 24, is more human-focused. So neuroscience to start. It's a field very close to some of the founders' hearts, and we will hopefully be expanding that to other fields in the future. But what we really wanted to focus is making this accessible for everyone in all types of levels. I mean, I personally will be able to use this. I have a background in psychology, so it's pseudoscience. I'm not sure anyone recognizes it here, but it does work. And we'll be making it very accessible through our UX and data pipeline. So you'll be able to simply drop a PDF, a research article, into the pipeline. It will structure it as a knowledge asset for you, and then publish it and map it with the relevant ontologies to make it machine readable. And there will be financial and social incentives for contribution. You already touched on the financial side. The social side is something very close to me. I mean, personally, I think social capital is huge for open science, and I think all of you have experienced that in your troubles. Being paid isn't always easy at the start, but receiving some form of reputation and social aspect for the work you've done is really important, and I think it will continue to be so. So a bit of a shout out here. If anyone's working on some composable reputation system that they might want to plug in here, would love to speak afterwards. I'll be around. And then the jazzy future, we've actually already heard a couple of people speak about this earlier. It was very interesting to hear. We are looking to make this an autonomous agent-focused paranet, hopefully by the end of year 24. Why? I think we've already touched on this briefly. I'll go over again. If science is about finding truth in the most efficient way, these autonomous agents are the ultimate truth seekers. They have less general biases. Well, remains to be seen as of yet on the training data. Citation games, they're not hanging around playing bibliometrics. And in terms of funding chasing, they don't necessarily need to be playing that game the whole time. They're not out at the bio rave tomorrow whispering in everyone's ear asking for money. They'll just be away working towards their general goals. They'll be making massive strides in overcoming risk aversion that we've heard from earlier today, creating novelty explosions and efficiency. They really are just exponential query machines. And paired with a knowledge graph where they can make all of the relevant connections, there just really is no limit to it. It's a very far-flung future. Eventually, these things will transition from research assistance to IP generation, and then translational science in the future. But first, we need our data and coordination layer, so that's what we're hoping to build. And I think we've got a good demo coming up for you, which George is going to try to do.
Yeah, let's see how the video performs here. All right, seems like it's going to work. Just before I click play on this, what we did for the demo was what Charlie mentioned. We transformed some of the scientific papers into the knowledge graph. created these highly connected knowledge assets, and built a DRAG, so decentralized RAG pipeline that actually, through this interface, finds, based on your query, right, based on your research question, the relevant pieces of information, and then feeds it to the LLM to generate an answer. So I'll press play now. Okay, so it's playing. So we'll just ask a question. I think this one is gonna be related to the Alzheimer's disease, to list all of the papers. So now the retrieval is happening, right? So the RAG is working. It's retrieving pieces of the knowledge graph. And there we go. We find an answer. We found these two papers. You can see the source knowledge asset over there. You can click on them. You can see a little bit of more details on the actual papers. We'll look at how these actually look like on the in graph form in a little bit. But for a second, we just take a step back and ask a follow-up question, also related to to the Alzheimer's disease, and specifically specifying, like, use the gene graph ontology to answer this question. Same thing happens, right? We find the appropriate knowledge asset, appropriate pieces of the knowledge graph that is able to extract this and then provide the answer. And now if we go into the knowledge asset quickly and actually open it on the graph, and I see I got 1 minute. I think it's just 1 minute left anyway. So open it in the DKG Explorer. This is Decentralized Graph Explorer, Decentralized Knowledge Graph Explorer. It loads, and actually you can see the graph form of the scientific paper, which was a PDF before we transformed it, right? And here you can see how this actually looks like. So we got the knowledge assets represented, then we have a bunch of objects that are representing paper contents, and results, and all of the exciting stuff that you would actually use in research. Now, the cool thing here is when we look at the resources, right? So when we go into the knowledge asset, we can see that this is actually using, so the paper was translated using a lot of different ontologies, from the SPAR ontologies describing the actual paper, to OB ontology that describes what methods were used, and then also gene ontology that actually kind of describes the results, right? So you have everything there that you need to do the research. And now I think actually the demo will end anyway. And yeah, I think just Charlie, if you wanted to have a couple of sentence or two of conclusion or anything to add. Yeah, there we go. Yeah, maybe, yeah. So maybe just a last sentence from me. So if you want to also become part of the OriginTrail verifiable internet for AI, help build solutions that contribute to advancing in this direction, feel free to connect. If you scan this, take you to our X account, and you have everything in there. And yeah, you can get involved with the upcoming paranets. We have the ID Theory DeSci Paranet. We will have a couple of others also up and coming, and yeah, we can help build this verifiable internet together. So I don't know, Charlie, if you want to add something, but that'll be it from my side.
Yeah, I mean, yeah, more of the same for me, really. If anyone wants to get in touch or get involved with the Paranet, the DeSci one specifically, please feel free to get in touch with Twitter or here. Yeah, I'll be hanging around afterwards. That's it. Thanks, guys.